All right, hello again, geometry kids. This is Inscribed Angles, our second lesson for the week of April 7th through 13th, 2020 on Canvas. We are doing Inscribed Angles. How exciting. I'm going to move down now. All right. In this lesson, we're going to learn about inscribed angles. An inscribed angle is an angle with a vertex on a circle and two sides that contain chords of the circles. Now, if you don't remember what a chord is, it's just any line segment that goes from one end of the circle to the other, right? So if this was my vertex, all right, really bad vertex, but that's my vertex, then right, this would be one side of my inscribed angle, a chord, the other side of my inscribed angle, another chord. This chord happens to also be a diameter. All right, and an intercepted arc has endpoints on the sides of an inscribed angle and lies in the interior of the inscribed angle. So the intercepted arc is the one that's between the edges of our inscribed angle. So this is one example of what an inscribed angle could look like. There's actually three different ways that it can look. So this is the example where one of your sides of the angle is a diameter of the circle. Okay. It could also be that, let me erase this all the way. Another way that they can look is with, oh, wow, that's really bad, guys. They could have, right, so we've got our vertex. I tried, guys, I really did. And one side is there, the other side could be, so this is when the center is between the sides of your inscribed angle, right? And the third way that a inscribed angle could be is that it could go so that the whole thing is just to one side of the center. The center isn't on the angle and it's not between the sides of the angle. So there's three different ways that it can be, and this is going to be really important when we're talking about solving problems and proving things about inscribed angles. So inscribed angles, there's three different types, and the only requirement is that the vertex be on the circle. Helps if I use my pointer on the circle, and then the sides be chords, okay? And the chords can be, one of them could be a diameter, they could both be on the same side of the center, or they could be one on each side of the center. All right, so there are a couple of theorems about inscribed angles. The first one is aptly named the inscribed angle theorem. Yeah, you want to write that down. If an angle is inscribed in a circle, then the measure of the angle equals 1/2 the measure of its intercepted arc. So that's saying, all right, here goes nothing. Here is a circle, a really bad circle. Try again. Here's a circle, right? Here's an inscribed angle. The measure of my angle, this guy, is 1/2 the measure of its intercepted arc. So if this was, I don't know, let's say it's 120, then the measure of that angle would be 60, both degree measures. All right, and Salcon will prove this theorem in one of the videos that I'm requiring you to watch for this week's assignments. It really is helpful to see the proof of a theorem, so I'm going to have you guys watch that. And yeah, so the second theorem, theorem 10.7, also want to write that down. I know it's a lot of writing on this slide, but the next slides, two slides, I think, are sample problems. So if two inscribed angles of a circle intercept the same arc or congruent arcs, then the angles are congruent. So what that looks like, I'm going to go over here with another really bad circle, right? If I've got this inscribed angle intercepting this arc, And then I have, say, this one intercepting the same arc, right? They're both covering this arc, right? That means that this angle and this angle are congruent. All right, so we got two theorems. We got a theorem about the measure of your inscribed angle. Oh, that circle's not as bad as I thought. It's pretty close. And then a theorem about, now I have to go find it again. There it is. And then a theorem about the inscribed angles intercepting the same arc or congruent arcs makes them congruent. All right, all of my drawings are gone, so I'm going to go ahead and just move on. If you need more time to write it down, go ahead and pause it so you can do that. All right, so we're going to practice finding the measure of inscribed angles given their intercepted arc measure. So for these three examples, I highlighted on all of them. You can tell I did it because it's really badly done. I did the best I could. The yellow is our inscribed angle. The green is our intercepted arc. So on this one, we've got inscribed angle FHG for intercepted arc FG, minor arc, right? 2 letters for a minor arc. G. There we go. All right. We know that FG is 98. That's given. We want to find out what is this angle. And our theorem on the previous slide, the writing goes with the slide, that's good, is that the measure of the angle is 1/2 the measure of its intercepted arc, right? So if our intercepted arc FG is 98, then that means our angle is 1/2 of that. So 1/2 of just means multiply times 98. So 1/2 of 98, 1/2 of 90 is 45, 1/2 of 8 is 4, 45 plus 4 is 49. So our angle is 49 degrees, right? And that's not too difficult, right? We think that's something you guys can handle. I think you guys can handle that. So this next one, FG again, is 60 degrees. Which means that angle FEG must be half as much. Half of 60 equals 30 degrees for that angle, right? Really bad arrow, but like you get the point, right? All right, and you notice that I did one of each type of inscribed angle. The one with the center in the middle, the one with the center on a side of the angle, and then finally one where both sides of the angle are on the same side of the center. And this one, we've got the same measure of the arc. See, it's the same. So the angle is also going to be the same. It's also going to be 30. And those are the simplest kinds of problems I can give you with inscribed arcs. I'll probably give you problems where you have to solve for x, but there'll be multiple choice on Canvas, because that is the easiest way to set up problems on Canvas is multiple choice. So I'll be doing mostly multiple choice from now on, guys. Yay you! Multiple choice. That's more easier sometimes. All right, so that is how you find the measure of an inscribed angle if you're given the arc measure. I'm going to go ahead and scroll ahead to the next slide. If you need one more minute to write them down, just pause the video. That's the good part about online is you can pause it whenever you need to. Okay, so now we're going to find the measure of intercepted arcs given the measure of the inscribed angle. So once again, our angles are yellow, our arcs are green. We're going to use red for this one. So our angle is 39. Our arc's got to be twice as big. So 2 times 39. Well, I know 2 times 30 is 60. And I know 2 times 9 is 18. So 60 plus 18, That means it's got to be 78 degrees for our arc. And then let's use dark blue for this one. Right? This angle is 51. The arc's got to be twice as big. Right? And this is all just what we know from our theorem 2 slides back, the inscribed angle theorem. Right? So 2 times 51. I know 2 50s is a 100. I know 2 1s is a 2. 100 plus 2 is 102. Pretty simple. Again, you'll be getting ones that have to solve for x, but I just want you to get the general idea of how to solve these problems. All right, and finally, we'll do this last one in green. We got 44 here, so our arc is going to be twice as big. 2 times 44. Probably don't even need to break that one up. You can just see 2 4s doubled. It's going to be 2 8s. And that goes there. So 88 degrees for this arc. All right. So hopefully that makes sense to you. If you need another minute, once again, just pause the video. You can do that whenever you need to. But hopefully these are pretty straightforward. And maybe you even were able to finish them before I did because of how slow it takes me to write when I'm doing computer stuff. Okay? Scroll in. All right. Triangles and quadrilaterals that are inscribed in circles. And remember, an inscribed polygon is just a polygon drawn inside the circle so that all of its vertices, its corners, touch the edge. That was a very bad example because my quadrilateral goes outside the circle. But we did talk about this right before spring break, what inscribed means. Okay, so theorem 10.8, an inscribed angle of a triangle intercepts a diameter of a semicircle, a diameter or semicircle, if and only if the angle is a right angle. So what that would look like, we're going to pretend that that's a circle. I'm going to erase a little extra bit. All right. So say this is my center, and if I have, right, let's make the center a little more obvious. All right, so if I have that, right, in order for this side of the triangle to be a diameter of the circle, this angle that's across from it has to be a right angle, which means it is a right triangle. So that is what theorem 10.8 is telling us. And then if a quadrilateral is inscribed in a circle, so we're going to draw a circle again. Once again, not a very good one, but we tried. And if a quadrilateral is inscribed in a circle, doesn't matter what the quadrilateral looks like. It can be any quadrilateral, or it can just be a vague whatever kind of quadrilateral, like it doesn't have to be a kite or a trapezoid or a parallelogram. All that we know, this says it's opposite angles, right? So this guy and this guy, they are supplementary. And the reason for that, let's use not blue, right, is because even if that's not a diameter, it's still, this is this much of the circle and this much of the circle. That's the whole circle, right? The two arcs together intercept the whole, the two angles together intercept the whole circle. And since the whole circle is 360, that means they have to intercept a total of 180, which means that they have to add up to 180. Did my words make sense there? Probably not. Okay, so this, right, because this is half as big as the arc, since the two arcs add up to 360, the two angles, which are half as big, have to add up to half as much as 360, or 180. If that didn't make sense, if you're confused, you can just reach out in office hours or email. and I'll try to explain it more. So once again, if you need more time, pause the video, try to draw pictures. You can probably draw better pictures than I did because you're using your pen on paper instead of mouse on computer. But yeah, pause it and get this down. All right, so we've got a couple of examples with inscribed triangles. See on this one, I marked the angle, that is 16x minus 16, and it says, okay, this is a diameter, which means that this angle intercepts a semicircle. So this angle has to be how much? If we look back at our theorem, it says an inscribed angle of a triangle intercepts a diameter or semicircle if and only if the angle is a right angle. So this intercepts a diameter, intercepts a semicircle. It must be a right angle, so we can set that up. 16x minus 6 is equal to 90. And then we just got to solve for x. So we're gonna what? Plus 6 on both sides. Plus 6, right? 16x equals 96. And then we got to get x by itself, so we divide out that 16. Divide out 16, right? X, I happen to know that 5/16 makes an 80. 96 is only one more than that, so it must be 6/16. You can also think about it, it's 12/8, so it's half as many 16s. So x has to be 6. And this is what I'm talking about when I say you'll get ones that have x's in them where you have to solve. It's just going to be problems like that. Right, and then let's do this guy, which is a little bit more confusing, right? So we've got this angle here, 61x minus 1. This angle here is opposite from 78, so it's half as big as 78. This angle here is opposite from 162, so it's going to be half as big as that. And there's more than one way you can go about solving this problem. The way that seems most obvious to me would be, since I know that each angle is half as big as the arc it intercepts, I would find what these two angles are and I would make them all add up to 180 and then solve for x. So we'll do that first, and then I'll do another way as well. So we've got 78, half of 78, well, half of 70 is 35, half of 8 is 4, 35 plus 4 is 39. All right, 162, half of 160 is 80, half of 2 is 1, so that means this must be 81, both in degrees. And we know since this is a triangle, they all have to add up to good old 180. So 81 plus 39 plus 61x minus 1 equal to 180. All right. Let's see, 81 and 39 and minus 1. Those are all like terms, so if we do the 81 with the minus 1 first, we've just got 80 and 39, which adds up to 119 plus 61x equal to 180. Subtract that 119 on both sides. So 61x. I happen to know that 180 minus 119 would be 61 just by like my brain. And then we would divide out the 61, which I can't write because of this me down here. So if I divide 61 divided by 61, I would get x equals 1. All right, so that's one way you can solve that problem. The other way, let me just do some erasing, is that I know the whole circle adds up to 360, which means that this 78 and this 162, whatever they have, we subtract that from 360 to get the remaining arc, right? So 78 and 162, that's 170 plus 7 is 240. So that leaves 120 here. All right, so then I know 61x minus 1 equals 120. Is that right? Let me just double check that with the calculator real quick. 360 minus 240. Yeah, so 120, 61x minus 1 is 120. If we, something's not right here. It's not 61x minus 1, it's 2 61x's minus 1, right? Because the angle is half as big as the arc. So we divide out that 2, divide out that 2, 61x minus 1 equals 60. We add the 1. And then we've got, once again, 61x equal to 61, which is the same thing we had up here. So we see x still equals 1. We just did it a different way. And that's a good way to check your answer, is that it should be the same no matter how you do the problem. Right? So give yourself a minute, pause the video, write that down. You don't have to write down both ways of doing this problem, but it might be helpful if you do. I'm going to erase the stuff that's off the screen, so make sure you pause and write it down before I get to the part that you need. All right, scrolling on. All right, and the last one's inscribed quadrilaterals. Do blue. So we have here 80, we have here 49x plus 2. We know that opposite angles in a quadrilateral inscribed in a circle, opposite angles are supplementary. So we scroll back down. 80 plus 49x plus 2 should add up to, supplementary means 180. So 80 plus 49x plus 2 equals 180. Okay, and then we've got our 80 and our 2. That's 82 plus 49x is 180. Okay, we subtract out our added on piece, that 82. We minus it. Sorry, my handwriting is so bad, guys. It's really hard with the mouse. I'm trying. All right, then I'm going to bring it up here. 49x equal to, and then 180 minus 82 tells me is 98. I just typed it in my calculator. We're going to try that again because that was like extra bad. 98. All right, and then we got to get x by itself, so we divide out 49. We did this 49 goes into 98 2 times. We found that out earlier when we were finding measures of the angles given an arc. So x on this is equal to 2. And then once again, we've got this more complicated one. So we have this angle, and this angle corresponds with the arc that goes from V through F to G, right? Because that's where the sides of the angle are. So we know that twice as much as 13x minus 2. 13x minus 2 should equal this guy, 16x minus 2, plus this guy, 9x plus 5. I don't have enough room to write all that, so I'm going to do my combining like terms here. 9x plus 16x. 9 and 16 makes 25x's. And a 5 minus a 2 is a plus 3. All right, then I'm going to go ahead and distribute the 2 this time. So 2 times 13x is 26x. 2 times minus 2 is minus 4. 25x plus 3 on this side. Got to get that 4 over to the other side. I'm going to add it. Right, because I don't like minus numbers. I like positive numbers. Right, gotta stay positive, guys. 26x is 25x plus 7. Right, and then we want to subtract out our 25x's over here. Minus 25x's. And if we had 26 and we take 25 of them away, it leaves just 1x. And on the other side, we have just 7. So we're done. I'm sure that there are other ways you could solve that problem, but that's the easiest way, I think. So hopefully this is helpful for you guys. Pause it, write it down. And then once you're done, you'll be able to go to Khan Academy and you want to watch the Inscribed Angles videos that I sent and do those Khan exercises. And then there will be a Canvas quiz, once again, not an actual quiz graded as classwork instead of a quiz. And you get 3 chances on each of those quizzes. I believe it only tells you that you got the answer wrong. It tells you what answer that you did. If it was wrong, it doesn't tell you the right answers until after you've done it 3 times. So like what I used to do is I would like write down the answers that I picked and be like, okay, so now I know it's not this one. And then by process of elimination, you can probably figure it out. Make sure you're also doing your math though, because yeah, you need to be able to do the math stuff. All right. So hopefully that's good. Enjoy the rest of your week. Reach out if you've got questions. Please attend office hours. Remember, they're boring if no one shows up. And your Inscribed Angles work is due Sunday by 11:59 p.m. So just midnight. Turn it in before Monday starts. Or like before I wake up on Monday. It will tell me if it's late though. So before 11:59. All right. Have a good day, guys. Be safe. Stay inside. But like try not to go crazy like I am.